Hey, welcome back. So we're going to continue looking at our acid and base chemistry and starting to see if we can figure out a little bit more about how we can start to determine whether we got an acidic or basic substance, and talk about some of the general properties that we start to see for these different substances. If you would, as a kind of continuation from our web quest, we know that we interact with these acids and bases all the time. And so here we've got our pH scale. We'll talk more about pH, but this is a thing we've kind of seen before and you've probably heard of. So we got a pH from 0 to 14 with 7 right here in the middle being neutral. So I'll give you a freebie. All of these little dashes represent an item on the following list. This dash right here on 7 is our water. And so if it's less than 7, that's acidic on the pH scale. If it's greater than 7, it is a base or basic substance. And so take a second, pause the video and actually rank these items for each little dash marks. What do you think would be most acidic all the way up to most basic? What would you think? Cool. Hopefully it was moderately easy. Some of these kind of give themselves away, things like battery acid or ant acid. We know water is going to be right here at 7, but it's a nice reminder that for a lot of the things we use, baking soda, hand soap, coffee, they are very much part of our pH scale and are different substances that we can start to be measuring and interact with on a daily basis. A couple of properties that you should be familiar with when we start to think about our acid and base chemistry. And at any point, if I'm going too fast, just pause it, record what you need, come back, keep going from there. For our acids, they do have a sour taste. Think about your lemons, your limes, your citric acids. I'm not saying go back in the lab and if you got a beaker of liquid, take a swig to see. We have other tools for that. But we happen to know, because we ingest some of these, we happen to know that they do have a rather sour taste. For our malonic acids or maleic acids, those are the crystals on the outside of your Sour Patch Kids for all of our sour candy folks. They are corrosive or caustic. Caustic just means that they will corrode the skin. So acids, we know, will eat away at things. Those H pluses start to react and pull electrons away and starts to break things down. They have a low pH, and we'll talk more about where pH comes from and how we get that value. But for our acidic substances, anything with a pH less than 7 is considered to be an acidic substance or an acidic solution. We're going to talk more here in just a second about indicators and how we can use them to determine whether something's an acid or base. One of the indicators you have actually seen before is phenolphthalein. I know it's a mouthful. I've never asked you to spell that. But in the presence of phenolphthalein, our acid substances remain colorless. They do not exhibit any color when we add this kind of substance, phenolphthalein. If we take treated paper, we call it our litmus test or litmus paper. If we put that in an acidic substance, it will turn red, kind of general red, danger, acidic, if you will. And they are electrolytic. They are electrolytes. This means that, and you've heard this with Gatorade before, right? Gatorade returns your electrolytes, and you know you need those electrolytes. Just mean it is a solution that could conduct an electrical charge. And so because we got these H plus ions floating around in there, we can shoot electricity through there. They are electrolytic. So here's what we would expect when we start to think about our acids and some of the properties of our acids. For our bases, they have more of a bitter taste. Think almond or coffee, even though coffee is technically acidic. But they have more of a bitter taste. Again, many of these pH substances are things we interact with. None of you have ever had this, ever. But if you've ever had to have your mouth washed out with soap for some reason, that's kind of the basic taste, that bitter taste. It does not taste pleasant. Bases are also caustic and corrosive. They actually react with the human skin faster than our acids. And so these, we got to be on the lookout and be aware for both of these when we're handling these, that we handle them appropriately, because both of them could cause damage if left untreated, unchecked for a longer period of time. Bases then would be greater than 7. If you're right at 7, you're going to be neutral like water. Higher than 7 on the pH scale, we consider that a base, our basic substance. In the presence of phenolphthalein, it goes that lovely kind of deepish purple kind of pink color, kind of the magenta color is what you end up seeing, a real deep purpley pink color. And so here's one of the ways. We don't have to taste it to know that it's an acid or base. We can add an indicator, something that will change colors based upon what ions, what chemicals are present. In presence of phenolphthalein, our bases go kind of lovely magenta pink color. We're going to see more of those tomorrow. Litmus paper turns blue blue for base, which is nice, lovely alliteration, BB, blue for base. And bases are also electrolytic. They also conduct electrical currents because, again, we have free ions floating around, and so our electricity can jump from ion to ion, or electrons can jump through there and conduct electricity. And so we got kind of a nice way to start to kind of just think about, okay, here's what we're seeing. Is this going to tell us whether it's an acidic or basic substance? Cool. Our indicators, a little more in depth with our indicators. Indicators are technically weak acids. Don't worry about that. But they're just a substance that will exhibit one color in an acidic solution and a different color in a basic solution. It doesn't necessarily, well, that's kind of a misnomer. These are just substances that show colors at different pHs. Kind of the one we use most often, especially in our early chemistries, is phenolphthalein. It's colorless in an acid and pink in a base. And so we can really kind of easily tell whether it's acidic or basic. Litmus paper was the other one we just talked about, red for acid, blue for base. But there's a lot of these. There's a lot of different indicators depending on what it is you're testing. Because sometimes, say you're testing, I don't know, a pill. Maybe you're a drug manufacturer and you're going to have a pill that somebody's going to eat. So you need to know how it reacts with stomach acid. And so you need a solution that is more closely aligned to your stomach acid. So different indicators can tell you at different bands or different areas in the pH scale what the pH might be. So bromothiol blue, another indicator. It is yellow in a more acidic solution and blue in a more basic solution. Methyl red is red in an acid, yellow in a base. And so here, our first color that's listed is the acidic or lower pH color. To the right is the more alkaline or basic color. So we got red in acid, blue in base for litmus, and can continue. And there's a lot of these. Universal indicator actually shows multiple colors. We saw this on the WebQuest. Cabbage juice does this as well, which is kind of cool. A naturally found indicator. And so universal indicator starts red, kind of goes green around a pH of 7, and then when it goes all the way to the base at 14, goes kind of a purple color. Phenolphthalein just changes when you make that switch from acid to base, which is kind of nice. But depending on what you're testing, like we said, methyl orange actually changes down at a lower pH. So this would be one you might use if you're trying to see if your solution is close to stomach acid. It's red at a really low pHs, but then when you get up here to 3 or 4, it kind of goes orangey yellow, and then it's yellow up into our higher pHs. And so depending on what it is you're testing, you've got very specific indicators you can use. Thionyl blue is another one, bromothiol blue we talked about, phenol red. And so again, different indicators for different purposes depending on what it is you're trying to test for. Some actual pictures from lab. Here's our phenolphthalein. 7 is kind of our normal neutral. So we really just start to see that color change at pH at 8, which is okay. It's pretty darn close. Phenol red goes kind of that yellow to pink. But then what do you call that orangish color, right? Sometimes depending on the colors, it's kind of hard to tell where you are in that transition. And so depending on what we're doing, we got different indicators for different jobs. A couple more examples here. We got methyl red, and you can kind of see that red color going to yellow, but again, you get kind of that murky color in the middle. Bromothiol blue, yellow to blue, but green, blue, light blue, just kind of depends. And it's going to be kind of up to our experimental judgment whether or not we've had a color change start to occur. Come back tomorrow. We're going to be looking at these indicators in the lab. We're actually going to test a bunch of these, see if you can find some patterns, use that to start to predict some substances, and we'll make sure we're feeling okay on these indicators before we move on to our pH scale. If you have questions, please don't hesitate to reach out.